This is Algebra 2 Practice Quiz 1.2. I am Mr. Sindel. Let's go through this thing. All right, number one, we've got a passenger plane and a jet, and they're leaving Tokyo at the same time. Ooh, if they're the same time, that unlocks a few extra features. The planes flew in opposite directions. Okay, so let's go ahead and draw a picture here. So they're starting the same place, same time. One is flying that way, one is flying that way. Those are opposite directions, right? One is a plane, one is a jet. So I'll say, and this one is the plane. We'll say P for plane, and we'll say probably J for jet. So underline the J for jet. They're in opposite directions. Okay, so what do we know? We're talking about speed. So let's go ahead and say we're dealing with speed here. In terms of the speed, the plane is flying slower than the jet. The jet is flying faster. So we'll say if the plane is flying at P, the jet is flying at P plus something, right? P plus 15. And this makes sense. We're adding 15 to the passenger plane to get the jet's speed. Another way of doing this is you could say that this is J and J minus 15, but I think this is the more logical way to approach the problem. Both of them are correct, though. All right, and it tells us 12 hours. So this is a time. So I'm going to come down here and talk about a time. And both of them start at the same time. So time here is 12 hours, and time also over here is 12 hours. And we have a distance. The distance here for both of them is, and I'll put this maybe in parentheses to let you know it's for both of them, is 9,900 kilometers. And the question is the passenger plane's speed. So the question is this P right here. If we can find that P, we're done. All right, so this is one of those times where because we're starting at the same time and the same location, what we can essentially do is take this plane's arrow and add it to the end of this arrow for the jet. If they're going the same direction, it's the same thing as if they're flying in different directions in terms of their distance. So I know that's hard for most students to wrap their head around, especially when I didn't have very good homework that assessed that. But if you have the same time and you're leaving from the same place, you can add them on to each other, and then they'll add up just as much as if they're going in different directions. So what I'm going to say here is I really have the speed is going to change here. I'm going to add these, right? So it's P plus 15. P plus P is 2P. Our new speed is 2P plus 15. And the time here is still 12 hours. They both fly for 12 hours, and they both now go 9,900 kilometers. All right, and we essentially just plug this into our formula. Remember that our general formula here is that distance is equal to our rate times our time. And we have a distance. Our distance is 9,900, so let's pull that over here. 9,900 is equal to the rate, or AKA the speed. We know our speed in this case. Our speed is now 2P plus 15, so it's going to come down here for our rate. So it's going to be 2P plus 15. And this is going to be multiplied by the time. And we know the time here is 12 hours. So it gets plugged over here for 12 hours. And we solve for P. Again, if we solve for P, we're done. The hardest part about this is setting up the equation by adding on both of these directions at the same time. All right, so we have 12. I can distribute that into both of these. Let me go ahead and draw that in here. 12 times 2 is 24, so I have 24P plus 15 times 12. All right, so 50 and 20, 70 plus a 10 is 80. So this is going to be 180. And that's going to be equal to 9,900. And then we just need to start moving our constants over. So minus 180 on each side, minus 180 on each side. That leaves us with 24P on the right side. On the left side, that's going to leave us with 9,720. All right, and then simply divide both sides by 24, divide by 24. I don't know what that is. Well, it's really close to 10,000 divided by 25, which I think is 200. So this is probably like 205 or something like that. Here, let me, instead of doing this mentally, we have a calculator for this one. All right. What is 9,720 divided by 24? 405. I was off. Okay. So P here is equal to 405. You don't need units, but I like putting them on there because I like to be as perfect as possible. This is a speed of kilometers per hour. So kilometers per hour. And I want to box that. Let's see if we got it right. You don't have to highlight on the practice quiz because you don't actually turn it in. 405, let's check though. It is 405 kilometers per hour. We got it. What about number 2? We have Trevon, who's driving to the town hall and back. So let's go ahead and draw a picture here. So we're going to start here, and we're we're going to drive to the town hall over here. So we're going to drive there to the town hall, and then we're going to drive back. Okay, and I want to give some room to talk about each of these. So let me move this down a little bit. And what do we know? It took 1 hour longer to go there. So let's say that this is the time, and this is the time. The time to go there was 1 more than it did to come back. So let's say that the time to come back is, I don't know, x. The time to go there is 1 more than that, so it's going to be x plus 1. Okay. The average speed on the trip there was 60. So on the trip there, that means going in this direction, the speed was 60. So I'll say speed. Maybe I'll do this a different color so it makes it pop out, right? I'll say that the speed here was 60. What's the speed down here? We don't know. Oh, the average speed on the way back was 75. We do know, sorry. 75. It tells us right there. 75 kilometers per hour. And the question now is how many hours the trip there takes. So it's this one that we're trying to solve for, not for x. You don't always solve for x. In this case, we're solving for x plus 1. So I'll put some question marks to remind us. We're trying to solve for x plus 1, which means what we'll do is we'll solve for x, and then we'll add 1 to it, and then we'll get x plus 1. All right, so notice that the distance is going to be the same. It's the same distance to get to the hall as it is to get the distance back. So essentially what I'm going to be doing here is I'm going to be making an equation that says distance equals the same distance. And we know that distance is rate times time, so my formula is going to be rate times time is equal to rate times time. And we know that. One of the rates is 60, because I'm plugging in 60 into this r, and then the time was x plus 1. X plus 1 is going to go into t, and I'm going to say that this is times x plus 1. Okay, over here, I'm going to have my other rate. So my other rate was 75 for this rate, so I'm going to write over here 75. This is going to be times the time x. The time is being plugged in, so 75 times x. All right, and then I essentially solve for x. And remember, at the very end, we'll add 1 to the x. So solving for x, let's go ahead and distribute 60 times x is 60x. 60 times 1 is a positive 60. And over here, 75 times x is a 75x. Remember that the left side has a constant on it. The right side has no constant. So the left side must be where the constants live. Let's go ahead and move the variable to the variable side, aka the opposite side of the constants, right? Let's go ahead and subtract 60x on both sides, subtract 60x on both sides, and I get 60 is equal to 15x. All right, I ran out of room, so let's come back up here. And if I have 60 is equal to 15x to solve, I would divide by 15, and x is equal to 4 hours. Remember, we found x. We don't want x. This is the one that has the question marks. We need x plus 1. So take this number, add 1 to it, and the final answer here is going to be 5 hours. And let's check. 5 hours. 5 hours. We got it. All right. Let's do number 3. Jack left the hospital and drove toward the lake. And 1 hour later, Jimmy left driving a little bit faster to catch up to him, and then they caught up. We need to find Jack's average speed. Okay, so what's going on with this picture? So one person has a little bit of a head start and gets caught up right here. The other person doesn't have a head start and catches up to the first person right here. So we'll say that this one is Jack, and this one is Jimmy. They're both J's, which is unfortunate, so we'll use x for a variable, I suppose. So what do we know about there's time and their speed? So what's the first thing that we see? They drove towards the lake, doesn't matter. 1 hour later, so 1 hour later than Jimmy. So that means Jack has been driving longer than Jimmy because Jack had the head start. Does that make sense? I hope it does. So let's talk about the times here. So for what color have I been using for time? Time has been red. So I'm going to come back here and change this to red. So for time, Jack has been going for X hours, and Jimmy has been going a little bit longer. No, sorry, that's backwards, isn't it? I just said it backwards. If Jimmy's been going for X hours, remember Jack got a head start, so he's actually been driving a lot longer. That's going to be X plus 1. I'm just making sure this makes sense. 1 hour later, Jimmy left. So that means Jack's been driving longer. Or you can say that this is X and this is X minus 1. Both, they're going to be the same thing. And then let's talk about speed. Let's do this in blue. So for our speeds, what do we know? Let's go ahead and say that Oh, we don't have any speeds. So let's go ahead and say our speed down here, 7 kilometers faster to catch up with him. So we need some more variables, I suppose. So the speed, let's go ahead and make a variable for speed, I guess y. If Jack is driving y miles an hour, or kilometers per hour, because we're in kilometers per hour, Jimmy is driving faster. He's driving faster by 7, so we need y plus 7. Y plus 7. Okay, and Jimmy drives for 5 hours. It says after 5 hours, Jimmy finally caught up, which means Jimmy has been driving for 5 hours. So I'm going to switch out this x for a 5, and if this was a 5, it'll be 5 plus 1, which is 6. So essentially I can come back in here and go like this. Whoa, that was too big of an eraser. Let's try that again. Jimmy's been driving for 5 hours. Come back here and do it in red. And Jack's been driving for 1 hour longer than that, so that's 6. After 5 hours, Jimmy finally caught up, and we need to find Jack's speed. So Jack's speed is that one right there. We'll put some question marks next to it to let us know that's the one that we're trying to solve for. If we solve for y, we're done. It's not asking for Jimmy's speed, otherwise we'd have to add 7 to our final answer. All right, so again, they're essentially driving the same distance. I assume that they starting? It's not very clear from the problem, but I'm assuming that they're starting at the same spot, and Jack just had a head start, so he's a little bit farther ahead by the time that Jimmy starts. So that means that the distances are going to be the same here. That's a case of where the distance is equal to distance. More than that, it's rate times time. So it's going to be rate times time is equal to, what's a bad equal to? Let's try that again. Rate times time is equal to rate times time. Rate times time. All right, so what is the first rate? I'm going to say the first rate is y, so we're going to do this one over here. We're going to say y times the time, which is in this case is 6, is going to be equal to rate times time. So rate in this case is y plus 7. So I'll say y plus 7 in parentheses, and that's going to be multiplied by time, times 5. Okay, and then we just need to solve for y, and that will be the answer that we're looking for. Excellent. So let's go ahead and distribute the 5 into the y plus 7. Y times 5 is 5y. 7 times 5 is a positive 35. Over here we have 6 times y, which is just 6y. All right, notice that the right side has a constant and the left side doesn't, which means this is where the constants will live. If the right side is for the constants, the variables must live on the left side. Let's go ahead and move that 5y by subtracting both sides of the equation by 5y. When we do that, 5y is gone, leaving us with just y, and that's equal to 35. And that's what we were trying to find. We're trying to find y. So we found the answer is 35. What are our units here? Well, 35 is a speed, and speed is kilometers per hour from the problem, so this must be kilometers per hour. Will I take off points if you forget your units? No, I don't really care about units that much in this class. I will let you know when I care about units, but the answer is probably almost going to be never. In physics, it matters quite a bit, though. So let's check. Number 3 should be 35 kilometers per hour. Number 3 is indeed 35 kilometers per hour. Excellent. All right, let's move on to number 4. Different type of problem. We got some percentages here. So this general formula, I'm just remembering, if I have a percent and then a quantity, I essentially have to do this. It's going to be, I don't remember what I said in the notes, but I'm just kind of going from memory here. I did like the quantity, I'm going to say QTY, that's not a plus sign, it's quantity 1 times the percent 1 plus quantity 2, that's QTY, quantity 2 times percent 2, all of this divided by the two quantities added, so quantity 1, okay, I need to do QTY, quantity 1 plus quantity 2, that's going to be equal to your average. So I'll say AVG. So what can we fill in this problem? And this is probably going to be the same thing that we're using for the next 3 problems. So the 53% sand is the first quantity. So there's a quantity of 6, and the percent is 53%. So filling this in, the first one is going to be 6 times, and here's the cool thing about these problems. You don't have to use this as a percent. You don't have to say 53% and then move the decimal to make it 0.53. Just leave it as 53, and all the units kind of cancel out, and you don't have to worry about moving decimals at all for these types of problems. Cool little shortcut. Okay, plus 1 yard. I guess this is a quantity, so it's going to be 1 times, and then the percent here is 60%, so times 60%, all divided by the two quantities added up. So the first quantity is 6, the other quantity is 1, so we'll do 6 plus 1 on the bottom. 6 plus 1, and that's going to be equal to sand content, the average sand content of the mixture. So we don't know what that is. We're searching for average in this question. We don't know what that is, which means we just need to simplify everything that's over here. And I can do that. So let's go ahead and, we don't really need an equal to sign in this case. So I can just simplify this fraction over and over. 6 times 53, well, 6 times 3 is 18, so there's an 8. I'll carry the 1 on my finger. 6 times 5 is 30, plus the 1 is 31, okay? Plus 1 times 60 is 60, all divided by 6 plus 1 is 7. 378, it's going to be 378 over 7. I can try to do this. I'm seeing this is the same thing as 350 plus 28. Both of those are divided by 7. 35 divided by 7 is 5, so this must be 50. 28 divided by 7 is 4, so the answer must be 54. 54, and it's what is the sand content of the mixture? The content is a percent, so it's 54%. Final answer without a calculator, just doing some quick mental math. Let's check. Number 4, 54%. Number 4 is 54%. Good job, Mr. Sindel. Pat on the back. All right. Kind of the same formula, I would have guessed, for number 5. Again, I think I'm going to go ahead. It's not a percent in this case, but I can just copy and paste this and show you how it's going to be related. So if I grab all of you, can I copy? Copy. And, oh, that's not what I wanted to do. I just wanted to, yeah, there we go. I just want to paste. So here's that. Ooh, I can make it even smaller. Technology, man, it's so nice. Essentially what I need to do is, instead of changing this into a percentage, I need to change it to a price. So I'm going to go ahead and erase these percentages. Erase, and put a money symbol in here. Money 1 and money 2, and now it all works out. All right, so what do we have here? Let's read the problem. I have an amount of bleach flour, but I don't know the amount. So I'm going to use B for bleach flour. So I'm going to underline B for bleach flour and U for unbleached flour. I think that makes sense. U and B. So we don't know how much bleach flour, but that's the quantity 1. So I'm going to say B bleach flour. So B is this first quantity, change it to B. We do know how much it costs. It costs $8 per ounce. So I'm going to put that down here. It's going to be B times 8 plus the next quantity. It tells us that the unbleached flour is 4 ounces. That's a quantity. So it's going to be 4 ounces times its cost. Its cost is going to be $4 per ounce. So 4 times 4. And this is all going to be divided by the two quantities. Remember, the first quantity and second quantity are B and 4. So I'm going to add those together. I'm going to get B plus 4. And that's going to be equal to the average amount. And it says the average amount here is going to be $7 per ounce. So it's all going to be equal to 7. So that's the hardest part, I think, of these problems, is setting up the equation. Now we need to solve the equation. So unfortunately, I have a fraction. Usually the first step in most times that I'm going to be solving equations is get rid of fractions. And there is indeed a way to get rid of the fraction right now, and that's going to be multiplying the left side by B plus 4. If I do it to the left side, I also do it to the right side, B plus 4. By doing that, the B plus 4 and B plus 4 cancel out on the top and bottom of the fraction, and I'm left with B times 8, which is 8B, plus 4 times 4 is 16. And that's going to be equal to, and I can distribute this right now, 7 times B and 7 times 4. 7 times B is 7B. 7 times 4 is 28. And then I have to choose which side I want my variables to be on. I want to put the 7B over here, because if I subtract 7B, I'll get a positive B. And if I do it the other way, I'll get a negative. So I'm going to say subtract minus 7B on the right, subtract 7B on the left. Now I have 1B, or just B, plus 16 is equal to 28. And from here, I can just subtract 16, and I get B is equal to 12. What are our units here? It's asking for how many ounces. So ounces are going to be, my final unit down here is going to be 12 ounces. So I'll come down here and say this is 12 ounces of bleach flour, if I'm being super perfect, but I don't need to be. So I'm just going to box that 12 ounces of bleach flour and 12 ounces. Perfect. I don't know why there's a dot S there. That's kind of weird, but whatever. All right, let's move on to number 6. All right, I have fruit salad costing 7. Again, it's going to be the same formula. So essentially, I'm looking over here as I'm plugging in over here. So Fruit salad is the answer. It's probably made from other things. It's made from peaches and bananas. So our average amount is 7. We can already fill in that right side. So the right side is going to be, I want to do this in a color that starts here. So 7. Okay. What about this fraction on the left? You combine peaches, and we don't know the quantity of peaches. So I'm going to leave that blank for now until I read the rest of the problem. But we have some peaches that cost 6, so something times 6, plus bananas, which we don't know either, and that banana is going to be times 9. And we need to find the number of ounces of sliced peaches and sliced bananas required to make 15 ounces of fruit salad. Okay, so if there's 15 ounces, remember, we're going to add the two quantities. The two quantities get added down here. We added the two quantities. We know the answer is 15. So I can say this answer is 15. I'm going to plug in 2 variables, and hopefully that'll work. So I'll plug in, what do we have here? Peaches, so P for peaches, and B for bananas. Those are our variables. So the problem that I'm seeing here is we have one equation with 2 different types of variables. Anytime that you have that, 2 variables means that there has to be 2 equations. Similarly, if you have 3 variables, that means you need 3 equations, but you don't usually see those that often in Algebra 2. So what was the second equation, Mr. Snell? What was this little piece right here? We skipped this piece and said, oh yeah, just plug in a 15. But really what we were saying is, hey, if we add together P and B, we get 15. And let me write that out explicitly because that is the answer. It's if I do P plus B, that should be 15. I don't know why that pen is so loud. Cool, so those are the 2 different equations. 1 equation, 2 equations. We need to solve either for P or for B. Either way will work. I have to find both bananas and peaches, so it doesn't really matter. I'm just going to go ahead and say B. I'm going to move you to the right side. I'm going to subtract P on both sides. So I'll say minus B, and I get peaches is equal to 15 minus bananas, B. Now that I know that peaches is 15 minus B, this peaches is also 15 minus B. So I can plug it in, right? I can say I have 15 minus B, and that's going to be multiplied by the rest of this equation, right? So it's going to be multiplied by 6 plus 9 times B, by the way, is 9B. All of this is divided by 15 is equal to 7. And I just need to solve for B. I have a B there and there. So what am I going to do? I'm going to do 2 things at the same time. I hope you're okay with me doing that. The first thing that I see is I want to distribute the 6 into the 15 minus B. So that's going to be 6 times 15. What is that going to be? 90, I think. 90 minus, and then 6 times B is 6B. And that's going to be plus 9B. And the other thing that I'm going to do is I'm going to multiply both sides by 15. I'm going to multiply this left side by 15 and multiply this right side by 15. And what will happen is this 15 and this 15 will cross cancel, and I have to do 7 times 15. So 7 times 5 is 25. So I'm going to write down the 5, carry the 2. The 2 is on my fingers right now. 7 times 1 is 7, plus the 2 is 9, so this should be 95. All right, so from here, I'm going to go ahead and simplify. Notice that we have two like terms, negative 6b and 9b, so that's going to be a 3b. So I have a plus 3b, and don't forget your 90, and that's going to be equal to 95. Ooh, this is looking really nice. And then from here, I just need to subtract 90 on both sides, subtract 90 on both sides, and I get 3b is equal to 5. Oh no, that's going to be a gross fraction. Did I do something wrong? I didn't try to make them come out as fractions. I am going to pause right here and be like, I don't think we have fractions. Let's check our answer. I have a suspicion that we're wrong. Yeah, do these look like fractions to you, 5 and 10? No, so I've made a mistake. I knew that I was going to be getting a fraction because I have to divide both sides by 3, and 5 divided by 3 is a gross 2.6 repeating. So I have made a mistake. And this is the time where I need to go back and comb through what did I make a mistake on. So we know that peaches and bananas add up to 15. That was pretty straightforward. We subtracted B, that seems okay, and we plugged that in for P. Everything looks good. Let's check this equation. Fruit salad, the average is 7, and it's made by combining peaches that cost 6 and bananas that cost 9. Okay, so far so good. And that's divided by 15 because they both add up 15. I think that equation is good. Let's go ahead and check the math down here then. 6 times 15, I did that kind of fast. 6 times 15, maybe that was a mistake. Well, 6 times 15 is the same thing as 15 times 2 and then times 3. So times 2 times 3 is the same thing as 6. So 15 times 2 is 30. 30 times 3 is 90. Oh, okay, I got 90 there. 6 times negative b is negative 6b. There's a 9b right there. So I get a 3b right there. Maybe I made a mistake over here with 7 times 15. Let's try that again. So 7 times 5 is... Did I say it was 45? It's 35. Maybe that was a mistake. I think I held up a 2 on my fingers and it's supposed to be a 3. I think this is the mistake right here. So 7 times 5 is 35. I'm holding up a 3 on my fingers. And then I wrote down the 5. 7 times 1 is 7. Add the 3 is 10, not a 9. Okay, so I did some mental math wrong. Let's go ahead and erase, erase, and erase. And I can fix this. This is going to be 10. And then 105 minus 90 is... Ooh, I want to change that to blue so it looks nice. 105 minus 90 is 15. And check that out. That number is divisible by 3. Okay, let's go ahead and divide both sides here. Divide by 3, divide by 3. B is equal to 5. Okay, we're not all the way done because it asks us to both find peaches and bananas. So we found bananas. We need 5 bananas. Well, if bananas is 5, 5 plus what is 15? By this equation, we know that peaches has to be 10. So I can say peaches has to be equal to 10. And technically our units here are pieces. So 5 pieces of banana and 10 pieces of peaches. Let's check. Banana 5, peaches 10. Bananas 5, peaches 10. And it's technically ounces of sliced bananas. I guess not pieces. I got the units wrong. It shows you that I don't pay attention that much. All right. Last 3 questions of the practice quiz. Here we go. These are straightforward, I hope. We need to first isolate the absolute value, so I need to get rid of this minus 1 by adding 1 to both sides. Negative 1 plus 1 is gone, leaving me with the absolute value of x is equal to negative 8 plus 1 is a negative 7. And then many of you will probably separate this into 2 different equations, but many of you would be wrong. How are you able to take the absolute value of anything and get a negative? That is impossible. So the answer here, as soon as we get to this point, is no solutions. There is no way that you're ever going to plug in, plug in negative 7. The absolute value of negative 7 is positive 7. You will never, ever, ever get a negative 7 if all you're doing is taking the absolute value of anything in there. So, no solutions. I'm going to check just to make sure I got that one right. No solutions. I said so confidently, and I might have got it wrong. But I was very confident for a reason. All right. Number 8, again, we are trying to isolate the absolute value. So I need to get rid of this 5 and get rid of this negative 4. Well, this negative 4 is being multiplied by the absolute value. This 5 is being added. I'm undoing PEMDAS, so I'm going to get rid of the plus 5 first. I'm going to subtract 5 on both sides. Subtract 5 on the left, subtract 5 on the right. This is going to be negative 4 times the absolute value of r minus 9, and absolute value is going to be equal to negative 28, which makes me worry because I had a negative in the last problem and it was no solutions. Hopefully I can get rid of that negative, and indeed I can because I'm going to be divided by a negative 4, divided by a negative 4, and a negative divided by a negative is a positive. 28 divided by 4 is 7, meaning that we have the absolute value of r minus 9, and absolute value is equal to 7. From here, you do indeed divide this into 2 different equations. The first equation, you just rewrite with no absolute value. R minus 9 is equal to 7. The second equation, you rewrite r minus 9, but instead of equaling positive 7, it's now equaling a negative 7. Solve each of these the exact same way. We add 9 to both sides, 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 and those 9s are gone. R in one case is equal to 16, which we should probably box, and there's a box. And R is equal to positive 2, which is the other case. So let's check. 16 and 2. 16 and 2. We got it. All right. Last question, guys. Number 9. Let's check this one. Okay. So again, I need to isolate the absolute value. So I need to get rid of this plus 8. So I'm going to subtract 8. So I'm going to say minus 8, minus 8. When I do that, you're gone, leaving me with just the absolute value of 7 minus 6n. And absolute value is equal to, what do we have here? This is going to be a 23. 23 plus 8 is 31. I think that makes sense. Yeah, okay, so 23. From here, we're going to undo the absolute value symbol by splitting this equation into 2 different pieces. The first piece is going to be 7 minus 6n is equal to 23, essentially just dropping the absolute value symbol. The second equation is going to be 7 minus 6n, which is going to be equal to the negative version of the outside, negative 23. Then solve each of these the exact same way. Get rid of the 7, get rid of the 7, get rid of the 7, get rid of the 7. When you do that, the 7s are gone, and you are left with a negative 6n, left with a negative 6n. On the right side, in one case we have a positive 16, in the other case we have a negative 30. Then, again, same way, divide by negative 6, divide by negative 6, divide by negative 6, divide by negative 6, and we get, those are gone, leaving us with an n equal to an n equal to. All right, I can simplify, right? I can divide by 2, divide by 2. A positive divided by a negative is a negative. So the answer here is going to be a negative 8 over 3. Positive. So 6 divided by 2 is 3, Mr. Snell. Thank you. Over here, I can do the same thing. I can reduce. I can divide the top and bottom by 6. I don't really need to do that. 30 divided by 6 is 5. A negative divided by a negative is a positive. This one is going to be a positive 5. I believe the two answers should be a negative 8/3 and a positive 5. Negative 8/3, positive 5, negative 8/3, positive 5. Does the order matter? I happen to get the last two in the exact same order that it asked for it. It doesn't matter. It could have been 5 and then negative 8/3. It doesn't matter. All right, and that concludes the homework solutions for Practice Quiz 1.2 for Algebra 2. Thank you for watching.